Welcome to some extra work on proportions. So we're going to start with some smaller numbers and work our way up into bigger numbers in scientific notation within proportions, but we're going to start kind of small just so that we can make sure we have the basic idea. So with proportions, a ratio equaling another ratio, we want to go ahead and cross multiply. And when I say cross multiply, I mean the bottom of one fraction multiplying by the top of the other fraction. So in this first one, I would have 3 times x, and that is set equal to the other direction, which is 9 times 8. So to simplify, 3x equals 72, and then to finalize that, remember that the equal sign breaks this stuff in half. We have to do the same thing on each side. And on the left, since I have 3 times x, the opposite of multiply is divide. So I will divide each side by 3. 3 over 3 is 1, so I end up with 1x equals 24. And so you will notice that this value of x is 24. So we would say that 8 over 24 is equal to 3 over 9. And you'll see when I write it like that, if I would, oh, that doesn't come out nicely, but if you cross multiply with these, like you would end up with 72 equals 72, and that's exactly what we want. So that's the point of proportions is to make them each side equal. So in number 2, when I go ahead and cross multiply, so I get 5x equals, go the other direction, 606. Divide both sides by 5, and x equals 121.2. You might want to go ahead and hit pause, try some of these. If you get stuck, I'm going to work them all out, so you can always come back and watch. But it might be good practice to try as many as you can on your own first. Number 3, we end up with some decimals. So process is the same. 6.3x equals, now I go the other direction and end up with 21.667. Divide both sides by 6.3, and I end up with an answer of x equals 3.4. Number 4. Now we're getting into some bigger numbers, some scientific notation. And I'm telling you, the first thing I'm going to do with this is I'm going to deal with this right here. The fact that it says 1,000. I know that 1,000 means 3. So I'm going to just go ahead and rewrite this problem. X over 4 times 10 to the negative third equals 50,000. And you know what? Back up. I'm going to go ahead and write 50,000 in scientific notation as well. So that's 5 times 10 to the 4th over 0.4. 1,000 is times 10 to the 3rd. So now when I cross multiply, I get 0.4 times 10 to the 3rd x equals, and I multiply this way, 4 times 5 is 20. And remember, when you multiply, you add the exponents. Well, negative 3 plus 4 is 1. So now I have to divide both sides by 0.4 times 10 to the 3rd. Those go away, and I get x equals, well, 20 divided by 0.4 gives me 50, and then I end up with 10 to the negative 2nd. I get 10 to the negative 2nd because 1 minus 3 is negative 2. Okay, let me get rid of that so it doesn't confuse you. And you can leave it like that, but it does say round to the nearest tenth. So negative 2 means take my decimal and move it 1, 2. My final answer is x equals 0.5. Okay. Number 5, again with these words and things. Now, 8/10, when I rewrite this, 8/10 is the same as 0.8. So I'm going to leave it like that. 8 million is 8 times 10 to the 6th because million is 6. And if you recall, trillion is 12. And there's a couple ways you can do this problem. You could reduce the fraction on the right, but I'm going to go ahead and just solve this as a proportion right the way we did the last one so I stay consistent, because sometimes I think there's a lot to be said for consistency. So when I multiply across, I get 8 times 10 to the 6th times x equals, and I go this way. So now 8 times 0.8 is 6.4, and then I still have the times 10 to the 12th. So when I divide, I'm dividing both sides by 8 times 10 to the 6th. Oops, that's a 10, excuse me. And that puts me at x equals 0.8 times 10 to the 6th. Well, times 10 to the 6th means that my decimal is going to go 6 places to the right. So it's going to go 1, and then 1, 2, 3, 4, 5, 6. Remember, those are all zeros. So my final answer is x equals 800,000 for the value of x. All right, and number 6, the last one like this, at least on the front side of this page. We have scientific notation again, because it's fun, so why not? Multiply across. I get 3.4 times 10 to the negative 4th times x equals, so now when I go this way, I take 5 times 8.21, and that gives me 41.05 times 10 to the, and we add 2 plus negative 6 is negative 4. So, if you recall, we will divide by 3.4 times 10 to the negative 4th. And it's time to go ahead and divide. So when I divide these numbers, I get 12.1. And if you take your exponents, negative 4 minus negative 4, add the opposite, you end up with 0. Well, anything 10 to the 0 power is 1. I don't know if you remember that from back in the day when you remembered exponents. But essentially, because they are the same, right? 10 to the negative 4th over 10 to the negative 4th. This is the same as having 4 over 4. Whatever, right? They cancel each other out. So these will cancel each other out, and I'm left with just 12.1. Let's turn the page. Now we are into story problems. So it starts with the ratio of cats to dogs. Okay, so I'm talking about cats to dogs. Cats to dogs is 4 to 5. If 800 dogs, okay, well there's the ratio of 4 to 5. 800 dogs. Dogs are on the bottom, so 800 goes on the bottom. How many cats would we expect? So the missing piece is the cats. And we solve it just like we would solve the other ones. So we cross multiply. 5x equals 3,200. Divide both sides by 5, and you are left with 640 cats. Now, since these are story problems, your x's have meaning. So make sure you label them with whatever they mean, because that's important in life to know what you're talking about. Number 2, from 04 to 2014, Cubs wins to losses. So we're talking about wins to losses was 169 wins for every 187 losses. Well, they're making up for this year, aren't they? Anyway, they won 845 games. Notice, because they won, we're going on the top where the wins are. We're trying to find how many losses over that time period. So if you're a visual person, it might be very good to actually go ahead and put your, whatever you're talking about, wins and losses, whatever. It helps give you just, keeps you focused kind of on what you're talking about. So now when I cross multiply, I've got 169x equals 158,015. I divide both sides by 169, and I get 935 losses. For a problem like this, even if you don't know anything about baseball, you should know that you can't have like 3.2 losses. Losses come in whole numbers. So if you worked this out and you ended up with a decimal answer, you could be like, yep, I made a mistake somewhere. And you can go back and check it out. So sometimes it helps just to kind of have that in general, what should my answer be? Is it okay if it's a decimal? And in this case, it wouldn't be, but we have a whole number, so we're golden. All right, let's go to number 3. At a One Direction concert, I'm not going to judge, whatever, there are 2 males for every 23 females. So we are talking about males to females. So they said 23 females, and I have a point here. 2 males to 23 females. Then it says, if 23,675 people attend the concert, how many males attend? And you're thinking, what? They say people and not females or whatever. So what am I supposed to do? Well, let's go back to this. If there were 2 males and 23 females, that means there were 25 total. So I can say, you know what? Let's start a new thought process. And let's think males to total. So 2 males to 25 total means how many males to 23,675. Right, so the information they gave us at the very beginning didn't help us directly, but it allowed us and it led us to the information we needed. So then, once we have our males to total, please excuse me there, my hiccup, now I can do 25x equals 47,350, divide by 25, and we get 1894. So there were 1,894, Becky, label, males at the One Direction concert. Number 4, the ratio of North American butterflies to South American butterflies at a butterfly park is 5-3. So, just thinking about it, North American to South American is 5-3. At the same butterfly park, South American butterflies to European, so now we're going South to European, is 3-2. There are 60 North American butterflies. So that's the information they gave us, 60 North American butterflies. So part A, how many South American butterflies are? Well, we have north, we want to know south. So we can use our north to south thought process of 5-3 equals 60 to x. I know the north, so the 60 is good. I've got to find the other one. So when I do this, right, cross multiply, 5x equals 180, and that means there are 36 South American butterflies. So now when you go to part B, it says, hey, well, how many European butterflies are there? Well, the European butterflies have to go with that south to European. So I know that ratio is 3 south to every 2 Europeans, and I know there are 36 South American butterflies from part A, right? We got that from part A. So we want to know how many European butterflies are there. So 3x equals 72, and there are 24 European butterflies. I like that problem because it builds. There's a purpose of finding part A because you need it for part B. I think that's fun when you need things. Let's go to number 5. According to the U.S. Census Bureau, 760,867 people out of the total Illinois population of big numbers have a master's degree or higher in 10. If the number of people in Indiana with a master's degree or higher was proportional to Illinois, what would be the expected number of people with a master's degree given Indiana's population? So we are talking about masters compared to the total population. And we are comparing Illinois and Indiana. So now I kind of got to fill in the blanks, right? So for Illinois, I've got 760,867 over 12,419,293 equals, I don't know how many people there would be in Indiana because that's the question. What would be the expected number of people with a master's degree or higher? So that's where the x goes because that's what we don't know, right? So that's our unknown x. And then the population is 6,080,485. And I just want to throw out, notice how the population of Indiana is like half. It's not perfectly half, but it's close to half. So when you look at the number of people for your answer, it should be close to half. That, again, is just kind of a logic thing to kind of what your answer kind of should be. So if you get an answer way different than that, you know something is jacked up and you made a mistake somewhere. So when you cross multiply and divide, you should end up with 372,520, right around there for your answer of how many people would have a master's degree or higher in Indiana in 2010. Number 6. My gas tank is virtually empty as I pull into the local gas station. Regular gas is $2.87 per gallon. I've got $15. How many gallons can I buy? And we're going to round to 2 decimal places. So if I have $15, and I'm going to divide it by 287, right, because that's 1 gallon. You know what? Let's go ahead and set this up like a proportion. $2.87 buys you 1 gallon of gas. So this is money, this is gallon. We know we have 15. How many gallons can we buy? Okay, so that would leave us with 287x equals 15, divide by 287, which is where I started, I apologize. And we could buy 5.23 gallons of gas, right, which is not too bad. 5.23 gallons. Now that leads us to part B. Upon leaving the gas station, I need to travel 102 miles. If my car averages 22 miles per gallon, how many gallons do I need to make it to my destination. Well, now we're talking about miles compared to gallons. So my car gets 22 miles for 1 gallon. If I need to go 102 miles, how many gallons will I need? Well, not too bad, right? Cross multiply, 22x equals 102, divide by 22, and I need 0.464 gallons. So, I have 5.23, I need 4.64. Considering that, can I make it to my destination? And for our purposes, our answer would be yes, because if we would take 5.23 and subtract the 4.64, we would have approximately, that's a 2, we would have approximately 0.59 gallons left over. Now, that is assuming there's no traffic issues, you're not doing a whole lot of starting and stopping, because you know that can affect your miles per gallon. So a lot of things can go with it, but just playing the normal game, yes, you'll have a little over half a gallon left. So that, my friends, is page 299 to 301, Work with Proportions.